Okay, so let's do another example with the product rule. Okay, so we had, okay, yesterday we discussed some rules when you take derivative, right? When you take derivative, you don't have the freedom to take derivative each term. Okay, when it comes to product, when you have a product of two functions, you gotta stick with the product rule. Okay, product rule give you that. Okay, simple. Okay, not that complicated. Okay, so f prime g plus fg prime. Keep that in mind. Okay, so apply that to this. G equal x squared times u sub x. All right, and they ask you for g prime of 3. G prime of 3. Okay, this is very typical and standard problem. Asking for derivative at a point, at a number. Okay, 3 prime of 3. To get the 3 prime of 3, you need g prime of x, the derivative. Okay, right. Generally, what do you say? What do you call this? G prime is 3. Normally, generally, g prime of 3. Function. Function will be down here. This will be function. This will give you a value, a number, a constant. Okay, g prime of 3 you're going to give. But overall, everything we talk about derivative so far, that basically derivative at one point, right? Derivative at one point. That point is 3. Derivative at one point, slope at one point, slope at 3. That was meant. Okay, at one point at 3. Okay. This is everywhere. Right? 3 prime of x. Behavior of the function everywhere. Behavior of function at number 3. Okay. So to find the behavior, to find the derivative, to find the slope of the tangent line at 3, you need to find the derivative everywhere first. Okay. So that is what we're going to go for. Derivative everywhere. Okay. Which is derivative of this. Okay. Apply the product rule. Okay. Right? Product rule, because clearly we see that is a product. The product right here. That's a product of two functions. Okay. First function is x squared. This second function is u sub x. Right here, u sub x. Okay. Usually you put this like this. This is mean arbitrary. Usually you put it. You don't give it something specific. You call this arbitrary, random. So this is a random function here. Okay. Just treat it like a function. So I have a function multiplied by another function. Use the product rule. Okay. Product rule right here. F times g prime. Okay. Let's try. Okay. Let's expand this. Use the formula. See what you get. So you have that. What do you get here? Try that. Okay, let's see. Let's roll around here. Product rule. Plus. Yeah, very close. Plus.
Who am I supposed to plug these into?
No, use this product rule. So
okay,
F prime
okay.
G.
Okay.
No. No. Very good. Now, okay, you have that. Then plug in 3. 3 here, 3 everywhere at the X. And somewhere in there you're going to use these two. Very good, very good. 2x times u, okay. Keep going. Time. Right here, you're doing right there, right there. Oh, they don't ask 3 prime of 3. Oh, that's wrong. Okay. Good. G, okay. You, this one, for each one, this is considered, look at this is F, this is G. So write exactly like this, but for these two. Good, yes, plug in 3, correct. If you have the derivative, plug in 3. Okay, according to this formula, the derivative, where's that derivative? So F prime G plus 1. F G prime. See? F prime G plus F G prime. Okay. F prime, which is that? G plus F G prime. This is arbitrary. You don't know which function, so just U prime. Okay. Correct for the first time. But the F, okay, right here, G in this case, U, right? Okay, so you need G prime, this means U prime, not number 1. All right. Okay, so it's relatively easy when you see a function, a specific function, right? You can take the derivative of this, you can take the derivative of this, 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 but suddenly you see a u of sub x. You feel confused, right? Treat it like a function. So you have f. Okay, don't rush yourself. Take a moment, write out according to the formula. I have f prime g plus f g prime. Right? There. F prime g. Don't try to take the derivative in your head. Okay? Don't try to. We are calculus. We have the privilege of going slow. It's not about doing fast. It's about doing correctly. Okay? And by doing correctly, you need to take a notch down. Okay? 2x. Now, one by one. How about that one?
Could we plug in 3 so we get like the derivative at a point? And then
But right now, yeah, we're gonna do that. But right now we're still at the x. So this is everywhere. Right now we are doing this. We're gonna come to that. But in order to get that, we need this. The correct answer is you don't know. Arbitrary. You don't know which function is this. So therefore you don't know the derivative of that function. Then derivative is just like that. You don't know. Here, that is x squared. You know that is x squared. You don't know what it is. You just know that is some function, some random function. Then derivative of random function is derivative of random function. Okay? So you have that g prime of x. That is behavior or derivative everywhere. Now you go to the main question. Derivative as 3, then you plug in 3. 2 times 3, where do you plug in? You plug in 3 here, 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 here. So you have 2 times 3, u sub 3, plus 3 squared times u prime of 3. There. That's where you plug in. Okay. 2 times 3, everybody know that is 6. This is 9, right? What is u sub 3? Again, you don't know that function. But do you know u sub 3? Is there any information given to you? Right there. Right? Is u sub 3 is 4. U prime of 3 is 1. Now you have everything. Okay, 6 times 4 9 times 1. Okay. All right. Any question? So that is how we're going to deal with the problem that have arbitrary function. Previous example, you have arbitrary numbers, arbitrary constant. I'm going to scroll up a little bit here. This example, arbitrary constant. So treat it like constant. So when you take derivative, they just some constant in the front, right? Put it in the front. This example, you have arbitrary function. Treat it like a normal function. Because you don't know, then write out you don't know. But don't just write out I don't know. I don't know this means I don't know, right? You don't know. The derivative is just derivative. Okay, so that is product rule. So power rule, product rule. Trick, now quotient. Okay, quotient, that means when you have a division a quotient, a division of two functions. Oh, this is going to be getting a little bit complicated, okay? The derivative of that, first of all, I want to emphasize, you don't take derivative one by one. Okay, I want to emphasize that. It's not just a derivative of numerator divided by derivative of the denominator, not that. In fact, it's going to be a little bit longer, but to memorize this formula, first of all, write out the denominator square. Okay, nothing with the denominator, just square that. G square. In the numerator, you have exactly the same like the product rule. You have exactly the same like the product rule, the pattern. But what's the difference? Because the quotient, you're going to have the subtraction. There, right? Product rule, you have this, right? But you with the plus sign, right? Quotient rule, you have exactly like that, but the minus sign. And then you divide it by the denominator square. Okay, so that when I do the product rule, this is the first thing I write down. I bring the denominator over here, I square that first, okay, and then I take care of the numerator later. Okay, how about you try that? Okay, the formula is still there. So y prime, first of all, when you do this problem, do not write like this, equal, and then write, you don't do that. They are not equal. You want to do like this, y prime, and then you write out the expression. Okay, quotient rule. Ratio. And don't try to explain. When you take derivative, you don't need to simplify. Okay, you see the square down here, keep it like that. It's not about simplify problem, it's about taking derivative problem. So just take derivative, leave it like that, that's good. Okay, don't simplify. Just put in correct place, correct order, correct derivative. Okay. U prime correct. Okay, minus. Yeah, there you go. That's it. That is answer. Okay. I think there's another. Next, you can keep going with the next example. But that's good. That's good. Hold on. F prime. Which is F? Which one is F? Then F prime will be cosine. Right, F prime 3, and then the other one too. Okay. Yeah, you write it out is correct. Technically, you're writing the prime, right? Oh, actually, then equal. That's correct. Write it out, and then equal. Now check the derivative. Good, good. There you go. Good. Okay. So I have, first thing first, every time I do this quotient rule, I always start with the denominator. The denominator is xq plus 6. I square that. And leave it there. I'm not going to expand that. Okay. Now numerator, technically the one on the top will be the first to take the derivative, right? F prime. So the top is psi. Want the derivative that F prime g minus f g prime. Right? Yeah. Some of you write like this first. That is very good. Don't try. I prefer you write like this first and then take the derivative. Because later on, why is this? This prepare you to do chain rule. Later on, maybe like this. You're going to take the derivative, something like that. Then you're going to take the derivative. Think about that problem. Think about that. The numerator. Try to take the derivative of that in your head. Right. More than that. Cosine 3x. Right. And then the derivative of the denominator is 2x minus 1 over x squared. Okay. But how do you do all of that in your head and then write out at the same time, right? So therefore, I prefer you write like this with the derivative. Okay, like this with the derivative. And now, okay, term by term. But one more time, the denominator, like a luggage, just carry with you. All right, copy and paste. So I have cosine of x, xq plus 6 minus sine of x. The next derivative will be just 3x squared. Okay, and also write carefully. When you write sine of x times that, whether you write them kind of far away or give it a parenthesis to tell that different. They are two different functions. Try to avoid writing like this. What does it look like? It looks like sine of the whole thing, right? Right? Try to avoid that. Many ways. Okay, first you can do this. All right. Split them out a little bit. Okay, that's it. When I tell you don't simplify, that means that is the answer. You don't need to distribute. You don't need to expand. Right? Leave it like that. Okay. So for quotient rule. Now quotient rule with something else. And just so you know, I think I haven't given you this formula. E. Okay, first of all, raise your hand if you know what does E mean. What does E mean? What is E? Raise your hand if you know that. No? No? Okay, not okay, it's okay. So that's why I asked. E is round. E, first of all, it's just a constant. Similar to pi. So E is a constant similar to pi. And is around 2.71, I remember correct. That's it. That's it. If you have an E button in your calculator, press E equal, it's going to round that. Okay, so first of all, treat it like that. E alone is a constant. Like pi, you're going to use that to do circle. Thing with circle, right? You do thing with trig, you do thing with circle. E is a number you're going to apply to do math with exponential function, which you're going to learn in chapter 4. Okay, which you're going to learn in chapter 4. Therefore, this one, for now, I'm just give you an introduction. It's just exponential function. It's very normal if you don't know E. Okay, but now you kind of know. Okay, exponential function based e. That's it. Okay. Right, base e. Another example of exponential there. Base 3, base 2, base 3, base there. Those are all exponential function. Okay. So this base e technically similar to 2.71 to power x. Okay. So that exponential function. Okay. And because it's exponential function, it's not a power function. It is not a power function. I talked about this yesterday, right? It's not a polynomial, so you cannot use the power rule. Therefore, it has its own formula, and this is also the easiest one. This is my favorite derivative. This is my favorite derivative. Why is that? The derivative of e to power x exactly the same. That's the beauty of this. So this is exponential function with base e. Then you take the derivative, you return exactly the same function. Nothing changed. Okay. So with that, this is what we're gonna use. Apply this. Now try that. Apply. So when there you're gonna see the quotient rule, right? So when there you're gonna see the e to power x prime. Okay. Go ahead. Try that. Y prime. I give you the first thing. There. Okay. Let's work out the numerator. Let me know if you have questions. Prime G, however, I kind of like trick you right as this one, correct? Oh, I like it. I really like when you write like this, so you can plug in, correct? Very nice. However, this one, if you have x cosine only, that is correct. But you have x in the front,
wouldn't that just be
that would be product rule. X times cosine. You're gonna go back. It's like another one. You have something look like this. There.
Okay.
Okay. Check it like a trick problems, right? Yeah. Close, but so f is this one, right? So derivative of this.
It's one function. It's not two.
That's one function. So you're gonna have the product rule for this, and then time this. Okay. Okay. First of all, this one is not easy. It's not easy. For now, it will be easy. I hope. No, I hope. Nope, not hope. Hope is an incorrect word. It should be easy in a week or two. Okay, it should be easy. For regular semester, it should be easy in around half a month. Okay, but for you guys, by the end of this week, this problem should be easy. You should be able to recognize this pattern. Okay. Again, you don't want to take the derivative in your head. You want to write out f. That is f. This is g. Right. I see that the pattern that you write out f and g, that is a good habit. Write out f and then f prime g minus f g prime. Beautiful, right? Term by term. But that one I'm gonna write like this. I'm just clean it. Okay. Do you understand this? Power, you just multiply these two power, okay? Power rule. X times 2, 2x, okay? But the numerator, tell me, Which one in there? You know right away the answer. That one right there, right? Just e to the x. This one rewrite. This one also copy and paste. The minus copy and paste. The only thing right there, there's something hiccup over there, okay? I leave it blank, okay? I leave it blank for now. That copy and paste. Minus x cosine of x. Because e to the x, apply right there. That is my favorite for a reason. No work done, okay? X cosine x, derivative. If it's just cosine, okay, so life so beautiful, right? Right? Or if it's just only x, you also know the answer. But this is x time cosine of x. Don't give me the answer. Give me how you're gonna do this. How you take the derivative.
Use the product rule for x times cosine x.
There you go. Time product, right? Product rule, just for that one. Product rule of this one, okay? It's just not x only, it's not cosine only. So the derivative of these two, not negative sign, not one, is something more than that. So I'm gonna put it on here. That is why, how can you take the derivative of product rule in your head right away, right? You're gonna write out on a scratch paper, I want to take the derivative of this, where I apply product rule. Okay, maybe you can go faster now. 1 times cosine of x plus x times negative sine x. Right? Product rule. Literally copy, paste that inside. Zoom it down a little bit. Snug that in there. Nice and easy. There you go. Okay, don't simplify. I don't need you to simplify that. I just need you to apply the correct formula at the correct place, in the correct order. Okay, so far good? Okay, it's okay, complete it's okay if you cannot do that before I give you the answer. You're not able to do that. Okay, it requires a lot of practice. Okay, that's why we have the homework, right? Okay, next one. This problem, I want you to do this problem in two methods, two directions. Okay, so in other words, you're gonna do one by one. One of them, I give you the idea right away. We are in quotient rule, right? So yes, one of them will be quotient rule. And by doing this example, you're gonna see that quotient rule is a painful method, right? Quotient rule, the formula by itself is already complicated. Therefore, quotient rule is not the most optimized approach. Sometimes you're gonna figure out a better way, which is over here. Okay, so think about that. Okay, I'm gonna give you another direction, another way. Okay, much faster, much easier than this. Okay, but let's do the hard way first, the difficult one first. Okay, no pain, no gain, right? Right. Put the t-square on the bottom right away, right? T-square. F prime of t square, right? That's what you're gonna start with, the quotient t square. Then you keep moving forward. Yep, correct. Good. Yep, correct. Okay, so quotient rule. F prime G, F G prime. Right, F prime G, F G prime. Term by term. T square. F prime G, that would be 6t. Okay, and like I said, square root of t is very common, right? You don't want to write out t to power 1/2, and then you subtract blah blah blah, right? You want to do this? T. Okay, something about to broke. And that projector. Oh, okay, so that, right? This is very common, so apply that right away. Okay, so time t. So minus 3t square minus square root of t time
1.
time 1. Okay, so I'm not gonna write 1. Okay. 1. Okay. So that is one way. Look at that one. Nasty. Ugly, right? Ugly. There's another way. Like I said, quotient rule is like the backup plan. If you cannot think of anything else, then use a quotient rule. Before taking derivative, always try, give yourself around 5 to 10 seconds. Analyze this problem. Can I write this thing like this? Remember this technique. You usually combine two fractions into one, right? Using common denominator, right? I told you that in this semester you go the other way. Most of everything you've been learning in algebra, now you're gonna go backward. You break a fraction into 2. Can you write that out? Right? Can you simplify? How about the second one? Right? Okay, you can convert everything in exponent. You can convert everything in the exponent. Right? T to power 1. Okay. The first one is 3t. Leave it there. That look beautiful already. How about the second one? What do you do with the power? What is the operation? Subtraction. 1/2 minus 1. Okay. If you forgot this, if you're in my 112B, you shouldn't forget this. We talk about this many times. Right? Anyway. You shouldn't forget that. And if you're in 113, I think you've been also learn about this. Okay. So subtract. Right. That's what I did over there. 1/2 minus 1. 1/2 minus 1 is a negative half, right? That is just f of t. That's just f of t. After simplifying, I have that. Just tell me, taking the derivative of this versus taking the derivative of this, which one is easier? All right. This is 3 minus whatever the power rule gives you, right? Done. See? Okay, according to the power rule, I throw the power to the front. I subtract 1 from the power. Minus and minus is plus. There you go. And this, ladies and gentlemen, this is exactly the same as this. If you simplify that, if you simplify that one, if you simplify this, you're going to end up to this one. Okay. But isn't that the nice thing about learning math? The more tools you have, the better approach. You can pick a quicker way. You pick a shortcut. This is shortcut. Okay. Any question? Any question? So technique, the second technique, what can I give? What should be the good names? Good name I can give for that. Simplify. Simplify. Right? Simplify direction. You simplify first, and then you take derivative. Okay. Quotient rule. Done. Okay. Any question before I move on? 2.4. Application. Go back to that two thing again. Tangent line and velocity again. We're gonna redo 2.1 in 2.1. We find the tangent line, we find the velocity using the limit definition, right? Both of them. This one we find the slope. Technically we're looking for the slope. Remember that one? And this one we're looking for the velocity. Right? Looking for both of them. What did we do? We do this. Right? Did that. Okay, we're not going to do everything again, but this time we bypass all of this. We use formula. That's one thing we learned. After 2.3, we learn a bunch of formula now. So now we don't have to do that limit anymore. We're going to find a slope. It's snap a finger, okay? Right? And we can even better. Previously, when we find the slope of tangent line, when you do this formula, we're only able to do that to a very basic function only. You find slope of x squared, right? Something you can take limit, right? Or x, maybe 3x, something really simple, really basic, right? This time, you find something more complicated. Here, x times square root of x. And we don't have to do limit with that, okay? All right. And because we're going to do this problem so quickly, tangent line. Take you maybe like 2 minutes to do this one. Therefore, we have time to find different things too. We're able to find a normal line. We're going to find the parallel lines. Okay? All right. So if two lines are said to be, before we find the normal line and parallel lines, we need to know their properties. If two lines are said to be normal or perpendicular or orthogonal to each other, okay, I use a bunch of synonyms, right? They basically form a 90 degree to each other, right? There you go, two lines like that, right? If they are normal, perpendicular, or orthogonal to each other, that means they form a 90 degrees to each other. Then their slope is negative reciprocal. Is negative reciprocal of each other. What does it mean? What does it mean? Let's call this is MT, the slope. We're talking about the slope first of all. It's always about the slope. It's always about the slope. So the tangent line called that m of t, the normal line, the slope is m of n, the parallel is m of p. Okay, so there, t and p, right? Normal, tangent, and parallel. Then what does it mean by negative reciprocal? So these two are negative reciprocal of each other. These two. How do I write that? Negative reciprocal Or you can just flip this. Okay. Or there it is basically the same. You can switch their place. These two, negative reciprocal, negative reciprocal. Okay, or you can flip them. Okay. That is when they are normal line. So in other words, later on you're gonna find normal line, right? You're gonna find normal line. You're gonna find normal line. But what do you do? What do you do? You find the tangent line first. You get a slope. Then find normal line. Find the normal line. You just do this. You get the slope of normal line. Okay, and then you do the point slope. If two lines are parallel, then the slope is this one much easier. The same. Yes, equal. So the slope of the parallel line will equal the slope of the tangent line. Oh. This problem, I'm missing something. I'm gonna tell you. Okay, first of all, honest. This is a mistake. I make a mistake in here. I'm missing some information for the parallel lines. We'll come to that. I need another point for the parallel lines, just so you know. So I'm gonna add something with this. But for now, let's find these two. Okay. So one by one. Find the tangent line first. Okay. Tangent line. To find a line, first thing first, tell me what do you need? To find a line, what do you need? It's all about the slope. Okay. Normally, in 2.1, how did you find the slope? Just tell me the idea, not the formula. How did you find the slope?
You find the derivative of the function.
You derivative function. And how did you find the derivative of the function in 2.1? Back in 2.1. You use a limit, right? But this time, you don't need that. In other words, you bypass that one already because you have formula now. There you go. All right, you don't need to do the limit. Okay, take derivative. Okay. Don't look at me. Take the derivative. Do that. I gave you the tools already. You don't need the limit anymore. Now you can do it. Take the derivative of that. Then you have the slope. Do I apply any rule here? Product rule. Once you did the product rule, finish the product rule. I want you to do another one without the product rule. Like I said, similar to the previous example with the quotient rule. There is another way to take the derivative of this one without using product rule. Okay, yes, product rule is absolutely correct, but do it one more time without a product rule. Try that. One more time without a product rule. Okay, that's the correct product. One more time without a product rule. So I'm gonna put it over here. I'm gonna do this example twice. Okay, F prime G plus F G prime. Okay. Right. Good? And that's how you do it, right? You get that? Right? F prime G, F G prime. Derivative. Does it? Okay. Without a product rule, assuming you don't remember a product rule, how do you do this? First of all, simplify, right? Technically, the simplify. Okay, go ahead. Okay. Okay. So simplify version. First, you want to rewrite your function in a nicer looking. Okay. X times square root of x. Square root of x. One more time. We've been writing this many times, right? 1 over 2. Right? 1 over 2. X is x to power 1, right? Now what happened there? What can I do with those two? You're gonna add the power. And 1 plus 1/2, 3 over 2. There you go. The derivative will be, use the power rule, 3 over 2 x minus, 3 over 2 minus 1. There you go. So this over here, one more time, if you simplify this, you're going to have this. Okay. Okay. I'm going to moving forward with this problem using the left, the one on the right. Using the one on the right. Okay, so I'm going to box this one. They're basically the same, huh? Just so you know. Simplify, you're going to get the one on the right, but the one on the right look cleaner. Okay, so 3 over 2 x to the power 1 over 2. I have that would be the slope. That's basically the slope of the tangent line. So you're going to use the point slope at, what is the point? 1, 1. P 1, 1. The point slope is going to have f of x minus f of 1. Actually, let's slow down a little bit. Y minus y1 equal m sub t x minus x1. Okay. At 1, 1, you're going to have y minus 1 equal m sub t, 3 over 2, 1 to the power 1/2, x minus 1. Okay. What did I just do here? First of all, Poisson formula. Everybody know this formula, right? Can you write this on down? In here, you need to plug in a point and a slope. Point right there, x1, y1, right there. 1, 1. That is what it means, point slope. 1, 1 point slope. The slope right there, which is that. Okay? And the slope at 1. The slope at 1. So I plug right here. I plug that 1 over here. So that's why I write there. Okay. So now clean this up. You have the tension line. Okay. So y minus 1. 1 raised to power 1/2. 1. Time that, multiply that to 3/2. It's still 3/2. Okay. Y equal 3/2 minus 3/2 plus 1. Right. Distribute 3/2 minus 3/2. Right. And then plus 1 both sides. Plus 1. Over here. Oh, missing the x. Thank you. Negative 3/2 plus 1. Negative 1/2. So this is the tension line. Okay. So tension line. Somehow I'm running out of space, so I'm gonna add another page right here. Okay. So tension line done. Normal line. When you got tension line, find normal line, find parallel line, extremely easy. Normal line, the normal line to that line at the point 1, 1, basically the same line with the different slope. So the only thing you're going to change is right here, right? The only thing you're going to change is the slope. The normal line, by default, normal line has the slope mn, right? That is negative reciprocal of the slope of tension line. All right. Therefore, you have negative 1 over the slope of tension line is 3/2, right? That give you negative 2/3. Okay. You have the slope of no, yes.
For the equation for the tangent line, how come you took away the square root or like the x to the 1/2 in the answer?
Which one?
For the tangent line at the bottom of like page 7, I think, right here.
Right here.
So when you get the derivative, you got 3/2 x to the 1/2. So why do you take out the 1/2 when you write the final answer? Is it just because it's at 1, 1?
Oh, you mean 1/2? Right, 1/2? Okay. So over there you have x to the power 1/2. The slope, general slope everywhere, x to the power 1/2. Then specifically right here when x equal 1, I plug 1 in the x, right? And now it's just a number. So 1 raised to power 1/2, technically square root of 1, right? And this quantity is 1. So that 1/2 is gone. Or that's 1/2 is calculated in here already. Okay, so 1, this quantity right here is 1. 1 multiplied by 3/2 is 3/2. That's why I have this.
Okay.
That's why we don't have that 1/2 over there anymore.
So if you leave the 1/2 in the answer, would that make it incorrect?
If you leave it 1/2 in the answer, I assume your answer, maybe I try to write your version of the answer. Okay, maybe you looking at something like this, right?
Just got 3/2 x to the 1/2.
Okay, x to the 1/2. Okay, I understand what you mean. So you want to look like this. Now this is incorrect. Earlier, okay, if you have 1, then yeah, it's correct but not simplified. Yeah. x. So this is the slope. That is the slope right there. That is the slope. If you put the slope, this is the slope everywhere. That x is arbitrary. This is slope everywhere. For this particular problem, they want the slope at exactly this point. So that you see where it's wrong.
So just simplify it.
Okay, not really simplify. Plug in. Plug in at exactly x equal 1, right there. Okay. Any question? Yes. Good question. Any other question? So this is everywhere. Therefore, that would be not the answer. So that, okay. Okay. Any other question? Okay. Let's circle back to the normal line. Okay. So you have the slope of the normal line is negative 2 over 3. Then the normal line, the equation of the normal line would be y equal negative 2 over 3. You rewrite the same thing, x minus 1 over 2. Okay. How quick is that? Basically, that same line. Normal line, tangent line. Basically, the same line over there. The only difference is the slope. All right. The slope, how do you find that slope? Negative reciprocal. Negative reciprocal. Okay. All right. Third, parallel. Okay. But this problem, this is where I want to tell you that where P11, right? Where is that? Okay, P11. Okay. Can you add this one? Parallel that passes. The parallel line need to passes through another point. Let's put 0, 0. Pass through origin. Okay, 0, 0. Okay. Now, the parallel line, the slope of parallel line exactly equal or the same as the slope of the tangent line, which you also found above, that is 3 over 2. Okay. Why do I add this information? In other words, do you recognize my mistake? Do you see my mistake? Why did I fix that? Why did I add that information?
Because any line that has that slope is parallel. So like if you want a specific line, then you have to tell the point it goes to.
That's one thing. Or if I ask you, okay, I have a point 1, 1. Okay, let's say this point 1, 1. 1, 1. There. I just found this line, the tangent line right there. That is tangent line right there. And then I ask you, if I don't give you another point 0, 0, if I don't give you another point 0, 0, I ask you, okay, find me another line that parallel to this, that also passing through this point, that also have the same slope. How do you draw that line?
Same line.
That would be the same line, right? That would be the same line. If I ask you what is the parallel line to this line, passing through the same point, has the same slope, the only way you can draw that is that line on the top of this one, right? Which is not parallel, actually. So that's why I asked you to passing through 0, 0. Okay, something like that. So parallel line. Okay, so now you have the point, you have the slope, point slope again. But this time much easier. Y minus y1 equal m sub p x minus x1. Because this point this time is 0, so you have a 2, 0 right here. Right, you have 2, 0 right here. You have 3 over 2 here, and you're done. Done. Okay, any question? Okay. So what is the takeaway? Key takeaway from this example? Can somebody tell me a few key things takeaway from this example?
The only thing that changes would be the b value in the line equation.
Okay. B value change. I mean overall the whole thing. Yes. Okay. You just say okay. Let's say one of them is in here parallel. I'm talking about this whole example. Starting from where I find the tangent line to normal line to parallel line in terms of tangent line problems. What is key takeaway? First thing you can notice, what's the difference between this one and the version that you did earlier in 2.1? Huh? You didn't use this limit. That's the best thing about this problem, right? Back in 2.1. Bless you. Where was it? This is 2.2. There. In 2.1, we've tried to figure out this t. What did we do? We did this. See? Look at the one that I'm highlighting right now. Right? That was your version in 2.1. This was your function. If I ask you this same problem in 2.3, what will be the slope right away? I'm not going to put out the answer. What will be the slope of this one? That will be 2x. That's what we're looking for. At 1, what do you do? 2 times 1. There. That's a very big difference, see? Okay, so in 2.1. And back to this. Next thing. So see how the problem, that basically the problem in 2.1. You drop down to just a few lines down there. The two things that I introduced in this problem, two new things are two new things that I introduced. Somebody else? Somebody. Normal lines and parallel lines. Normal line and parallel lines is all about the slope for each one of them. And these two are the property. One is a negative reciprocal when you have a normal. The parallel even easier, the equal slope, right? Okay, so using that two properties, find the normal line for a parallel line. Okay. All right. Any question? Any question?
You could point slopes in the parallel line.
Mm-hmm.
Why didn't you use it in the normal line? Why didn't you plug it back into the point slope formula? Like when you took the negative reciprocal.
Okay, that's a good question. Why didn't I use the point slope for this one, right? Because first thing I know the slope is this number, -2 over 3. Second, is also passed through the same point. Passing through the same point. In other words, that point may be right here, 1, 1. Okay, so the normal line will be like this. Okay, so I know the slope of this one is this number. I know it's also passing through this point, 1, 1, same like the tangent line. Passing through the same point, I know the slope. Passing through the same point give me the same b value right here. So I don't need to plug in again. You just technically find this. Change this one. That's good. Okay, you change the slope is good. Okay, good question. Good question. Moving on. Next application. Velocity. You're gonna do velocity again, same like 2.1, but without the limit. That is the goal of this problem. 2.4. 2.4 is 2.1 on steroid. Think of it like that, right? 2.1 on steroid. You do everything in 2.1, but in a much quicker way, right? All right. Find the bond velocity after 2 seconds. That means v sub 2 is the question. In order to find v sub 2, you need to find v sub x. And we learned that velocity is the derivative of the position or the distance, right? Velocity is derivative of the position or the distance or the height. In this particular problem is the height. Okay, and because we learned the formula, we're not going to do the limit. And somebody give me the answer right away. That would be 40 minus 32t. How beautiful is that, right? That is 2.1. We just bypassed 2.1. 2.1 was squeezed inside this equal. Right? It's 2.1 squeezed inside that equals. Right? And there you go. Then v sub 2 equal 40 minus 32 times 2. Okay. 40 minus 64. Right? 40 minus 64. That would be negative 24. Somebody give me a unit. Feet per second. Okay, I don't know why did I give this information. Okay, so yeah, and that's it. Okay, why negative? Not really. Slow. If you use the word slow or fast, speeding up, that's going to be acceleration. We're going to discuss that when we talk about acceleration.
Because like the ball's on the way down.
The direction, that negative, tell you that. Okay, so technically when throw the ball up, there will be a period of time. The movement is upward, right? Okay, and then there will be a movement that when there will be some time it's going to go down. So the ball look like this. Throw up, stop, right, and then dropping down. Okay, so by knowing that velocity is negative, so I know at least look at the velocity. I know it should be somewhere in here. It cannot be here. It cannot be like in the first half of the movement. It cannot be going up. It has to be on the way down. Okay, so somewhere in here. That negative tell you that the ball is going downward. Okay, physics. Okay, and also this is very true. Look at the height. Okay, I'm going to put this in the xy. Height is s of t. That is t. That's s of t and that's a t. Okay, this is a function of t. Look at this one. Look at this, bro.
So velocity
velocity is basically speed with direction. Like,
Yes, very good. Yes, velocity is speed with direction. Oh, I cannot explain better than that. I cannot define better than that. Speed is not the same with velocity. In Cal 3, you're going to discuss this. Speed to tell you the quantity of velocity. The quantity. The speed, that means you're going 50 miles per hour. That number, 50, that quantity, that 50. But when you talk about velocity, you talk about the direction. That 50 miles per hour, the car is moving toward me, is about to hit me or moving away from me. The sign in front of the number, the quantity, tell you the direction of the movement. And when you have the sign in the front of that, you have to use the word velocity. Okay. Okay, that's a very good explanation. Velocity technically included two things: speed and direction. Okay. Good. Now go back to this one. The ball movement, right, threw up. At some point, the velocity is going to slow down, right? Okay, smaller, until it completely stops. Okay, for a brief second, maybe a couple milliseconds, start falling down. The gravity pull it down, go down. This moment, what does it look like? In terms of equation, a parabola. A parabola, the model function is x squared. But what happened to this parabola? Upside down. So you're going to have negative something x squared, right? Right? See? This is consistent. There you go. Okay. I'm going to ask you this question. Maybe, yeah, I'm going to ask you this question. So part A, that is A. Huh? The velocity after 2 seconds, very easy. But next, how long does it take for the ball? Okay, how long does it take for the ball to reach its maximum height? And yes, C, part C, I'm just going to let you know right away. If you know this answer to this, I'm going to let you know. The next question I'm going to ask, what would be the maximum height? Okay, what would be the maximum height the ball can reach? But for now, how long does it take for the ball to reach its maximum height? Okay, think about that. The tools or the equation or the information required to answer that question is on the ball. Literally is on the ball. Somewhere is on the ball. Somewhere is in there. Somewhere in here. Give you the answer. Give you the information, not the answer. Give you the information to find the answer to this. You just have to understand the nature of this problem. Okay. So when you read these problems, you got to understand, you got to pick out the key word. So that's the question. What would be the key word? Give me a few key words. Maximum height. Also, you got to understand what is it looking for. So you have V, you have S, you have T. There's only three things in here.
It's looking for the t value where the function is at its highest.
Yes. How long? This is a question of time, right? They ask you how long you take. How long does it take you from here to work? How long does it take you to walk from here on the way to the gym down there? You're gonna say 2 miles. Are you gonna answer 2 miles? 1 miles? No, right? How do you answer? You answer around 10 minutes, right? 15 minutes, right? So understand the question. How long? Then a question of time. You understand? Okay, they're looking for t. Some t in there. What is the information that given to find that t? The maximum height. Okay. Then you're gonna check the answer. Just ask yourself a question: when do I get the maximum height?
The derivative is 0.
The derivative is 0. That's a very calculus answer. The derivative is 0. I want more physical explanation.
The moment where the ball is traveling up and it's about like where it changes its slope from going up to down, or like positive to negative. I mean.
Okay, from positive, basically right here. But that's still calculus. I want physical explanation. That's still calculus. More physical than that. Yes, that's still math. I want to shorten that answer. Okay, you don't want to explain that to a 12 years old kid. The keyword is right when the ball stop moving. Right, when you throw it up, all of your answers are correct, but the keyword I'm looking for is the stop. When the ball go up, at some point it has to stop. The moment that it stop, that is when we get the maximum height, right? Correct? It stop, then it starts to fall down. When the ball stop, you get the max height. And yes, you were correct. When the ball stop is when the velocity equals to 0. Do you have the velocity? There. Okay. So for t, mm, 40 over 32. Simplify that. How much should the decimal number?
1.25.
1.25. The unit here is second, right? So around a second, a little bit more than a second. Yes.
Since this is, excuse me, since this is a parabola and we have the equation,
Uh-huh.
couldn't you also just use negative b over 2a?
Oh, beautiful. I never thought about that, to be honest. Yes. Rare, even, yes, that is the beauty of math. You have as many tools as possible. The correct, yes, first of all, your answer is very good. You are looking for here the maximum right there, right? The maximum right there is when the velocity equals 0, when you have tangent line equals 0, when you have the slope right there equals 0. That is calculus. If you don't know calculus, go back to the pre-calculus. You didn't learn about derivative, but you know that it's parabola. A parabola always have, what is that, Paul?
Vertex.
The vertex, right? You're able to find the coordinate of the vertex. Yeah. Okay. In this case, to find the vertex, usually you use notation is h and k, right? Vertex of parabola, h and k, right? H and k. And then you plug in. How do you find the h? How do you find k? Negative b over 2a, and k is f of h. Okay. Right. That will be the time when this is h. That will be the time when we get the maximum height. Negative b. Okay, so let me write down the equation. F of x equal 40 minus 32t. No, is that 32? 40t minus 16t squared. Okay. Rewrite that. So I know which one is A, which one is B. There. B is 40, negative 40 over 2 times negative 16. Negative 40 divided by 2 times 16, 32. Negative over negative. There. 1.25. Second. There you go. Okay, so yes, very good. This is pre-calculus technique. Still apply here. Okay, then if H, the vertex, I'm going to write over here, the vertex is here. H and K. Therefore, the value of H stands for the x-axis. That right there, H, K here. There. Right, that is vertex. Vertex H and K. Okay. H right here, that is the time when they get to the maximum height. Then if I keep going with this vertex, I finish, I find that K by using this f of H. Okay. What does this one stand for? I'm going to get some number, right? What's that? A constant, yes, you get a constant, but what does it tell you? So H tell you the time it get to the maximum height, right? The moment it get maximum height at exactly 1.25 seconds, I get here. One Mississippi, there you go, that's it. Now I'm stuck falling down. Then H tell me that moment. K tell me, yes, the maximum height. Finish that, you get a maximum height. Blah, blah, blah. I don't know. Finish that, you get maximum height. Okay. Oh. Now you brought that up. Okay, I may ask you this. Oh, that's a good one. No, next semester. Next semester, I'm going to ask this. That's another way to answer this. Okay. So now you have many tools, right? Velocity equals 0. The tangent line, the slope equals 0. When the bone stops, or this basically a parabola, you find the vertex. Okay, you have at least four different thinking of this. Okay, let's have a quick break. So we technically close out 2.4 already. We're gonna come back at this is 10:56. We're gonna come back at the 11:10. Okay, 11:10. When you come